So today we are going to discuss about part 9 core Java API classes, and part .9 of that is string immutability, key methods and concatenation order traps. So the fundamental rule is that string is immutable. String s is equal to hello and s to uppercase system.out.println s, right? It will print hello, right? So we because here you see that we call, so as you see, we call to uppercase on variable s. You might expect s to now hold hello in uppercase, but it does not. S still holds small hello in lowercase. Okay, this is because string is immutable. Once a string object is created, its content can never change. Okay, to uppercase does not modify the existing string. It creates a brand new string object containing hello in uppercase and returns it. But we did not capture that return value. So the new string is created and immediately discarded. So small variable s was never touched. Okay. So capturing the return value. So if you do string upper is equal to s dot uppercase system.out.println upper, then it will print hello in uppercase. Okay. But if you just print here s and not upper, you will get hello in lowercase. Now we capture the return string into a new variable upper. Upper holds hello in uppercase, but s still holds hello in lowercase. Both objects exist independently in memory. The original was never touched. So we just have a new object alongside it. Reassigning the variable here, s is equal to s dot to uppercase. If we do this, then this is a valid and common practice. We are not changing the string object that s was pointing to. That is impossible. What we are doing is creating a new string hello in uppercase and making s point to it instead. So the old hello in the lowercase string still exists in the string pool. It just has no active reference anymore and will eventually be garbage collected. The variable changed, the original object did not. Okay, so concatenation works the same way. String a, say string a is equal to hi, and then string b is equal to a dot concat there. So system.out.println, if we do a, and a will get hi only, and system.out.println b will get hi there. Okay, so concat creates a brand new string hi there and returns it. A is completely unchanged. It still points to hi. B holds the new string. These are two separate objects and two separate variables. Okay. String literals, string pool, we are revisiting this in context of immutability. So string literals go into the pool. So string a is equal to hello, string b is equal to hello, then system.out.println a equals b, it will be true. So when Java sees a string literal, it checks the string pool first. If hello already exists in the pool, it uses the same object rather than creating a new one. So both a and b point to the exact same object in memory. That is why a equals b returns true. The equals or double equals operator, it compares references, that is memory addresses. Since both variables point to the same pooled object, the addresses are identical. So string operations that produce new heap objects, right? So we have string c is equal to a dot to uppercase. So it's a new heap object. String d is equal to hello. That's a pool object. So system.out.println, if we do c equals d, it will be false. And system.out.println c equals d, it will be true. So to uppercase creates a brand new string object on the heap. Okay, not in the string pool. It does not go into the pool, it goes to the heap. Meanwhile, d is a literal, so hello in caps, it goes into the pool, so as a separate pooled object. C and d contain the same characters hello, but they are two in uppercase, but they are two different objects in two different memory locations. So c equals d is false, the addresses are different. But c dot equals d is true. Equals compares content character by character, not memory addresses. So same characters, same result. This is the core lesson about string comparison. So use equals for content, never use equals unless you specifically want to know if two variables point to the exact same object. So why immutability makes the pool safe? So if string were mutable, sharing pool objects would become very dangerous, because a.replace creates a new string and pool objects are never modified, right? So think about what would happen if string were mutable and two variables shared the same pooled object. If one variable changed the content, the other variable would see the change to a silent, invisible side effect. Because string is immutable, this can never happen. When you call a replace or to uppercase or any other method, Java always creates a new object. The pooled object is never touched. See, it is perfectly safe for 1,000 variables to share the same pooled string, because none of them can ever modify it. Immutability is not just a design quirk, so it is what makes the entire string pool concept work very safely. So key string methods, right? Quick reference. So length returns the number of characters in the string as an int. So hello has 5 characters too, so length will return 5. So remember that this is a method, it has parentheses. Okay, this is different from arrays where the length is a field with no parentheses. And then charAt int index. So returns the character at a specific position. Indices start at 0. So hello.charAt1 returns e. So the character at index 1. So if you pass an index outside the valid range, negative or greater than or equal to the length, you get a string index out of bounds exception at runtime. Okay. And then we have index of string str. So returns the index of the first occasion of the target string. So hello.index of say ll, right? So returns 2 because ll starts at index 2. So if the target is not found, then index of returns index of returns -1. So importantly, it does not throw an exception for a missing match, just -1. Substring int begins, so returns everything from begin index to the end of the string. So hello.substring2 will returns llo, characters at indices 2, 3 and 4. And then we have substring int begin, int end. This is the one with the trap. The begin is inclusive and end is exclusive. Hello.substring 1.1, 3 will return el, characters at indices 1 and 2. Index 3 is not included. The end index is always excluded. This is the same convention as arrays.shortRange. Okay, so inclusive start and exclusive end. Then we have two lowercase and two uppercase. This return a new string with all characters converted. The original is unchanged. Okay, same immutability rule applies. So hello in caps to lowercase will return hello in small case, and hello in small case to uppercase will return hello in uppercase. Then we have trim. It removes leading and trailing white space. So hi.trim, before hi if there is a space and after hi if there is a space, so it will return hi without any spaces. Only the spaces at start and end are removed. Spaces between the words in the middle are kept. Okay. Again, it returns a new string. Original is unchanged. Then we have replace old, new. Replaces all occurrences of old character and substring with new one. Cat replaces C, B returns bat. Okay. Note that replaces all occurrences, not just the first one. So returns a new string. Then we have equals object and equals ignore case string. Equals compares the content character by character, case sensitive. Hello and hello in capital H and ELLO and hello with small capital H, small h, hello are not equal with equals. Equals ignore case does the same comparison but ignores case. So in this case, both will return true. So, and then contains char sequence returns true if the string contains the given sequence anywhere inside it. So hello.contains ELL returns true, returns false if not found. Okay. Then start with string, so returns true if the string begins with a given prefix. So hello starts with HE, right? It will return true. There is also an ends with method that works the same way for the end of the string. And then we have concat string, appends the given string to the end and returns the new string. Hi.concat there returns hi there. Okay, so functionally same as plus operator for strings. The original string is unchanged. Okay. Then we have string concatenation order, the left to right trap. So string concatenation order is one of those topics that looks simple but catches people repeatedly on the exam. Okay. So if we see the first example, system.out.println, then one within quotes and then +2 +3, right? So answer is what? 1, 2, 3. Java starts at the left. The first operand is the string literal 1. The second string literal 1, right, within quotes. So second operand is int2. So one side is a string, so Java performs concatenation, right? So 1 plus 2 becomes 1, 2. Once a string appears on the either side of a plus, that operation is a concatenation. And because we evaluate left to right, so everything on the right of the first string gets pulled into concatenation one step at a time, right? So it becomes 1, 2, 3. And then we have second example, system.out.println 1 plus 2 plus 3 within quotes, so it will become 33, right? Now the string is on the right, Java starts at the left again. First operand is int1, second operand is int2, both are ints, so this is arithmetic. 1 plus 2 is equal to 3. Now we have int3 and string 3, one side is a string, so it will become a concatenation. 3 plus 3 becomes 33, 3, 3, so final output is 3, 3. The position of the string in the expression completely changes the result, okay? So third example is 1 plus 2 plus 3 within quotes and then 4, right? So it will become what? 3, 3, 4. Left to right, 1 plus 2, it becomes 3, then concatenation, 3 and 3, then again concatenation, 4, right? 3, 3, 4. Then parenthesis, it forces evaluation order. So system.out.println result plus 1 plus 2 within bracket. So result is what? Result is 3, right? So parentheses are evaluated first before anything else. So 1 plus 2 inside the parenthesis is arithmetic equals 3. Then result plus 3 string and int, it will be concatenation. So will be result 3, right? And then null concatenation. So we have string s is equal to null and system.out.println value plus l, right? So value is null. Why you might expect this to throw a null pointer exception, but it does not. When null is used in a concatenation, Java converts it to a 4-character text null and appends it. The output is value null. Literally, the word null as a text. Okay. So bounds and runtime exceptions. The string hello has 5 characters at indices 0, 1, 2, 3, 4, 3 and 4. Right, length is 5. And then we have charAt, right? s.charAt 4 will be what? We have O, right? And index 4 is valid, so it is the last character, returns O, fine. So s.charAt 5 will be what? It will be string index out of bounds exception. Index 5 does not exist, so the valid range ends at 4. So charAt throws string index out of bounds exception. This is a runtime exception. The code compiles but crashes when runs. Then we have s.charAt -1, again string index out of bounds exception. Negative indices are never valid, same exception, okay? So and then we have substring. So s.substring 2. So f.substring 2 will be LLO. Returns everything from index 2 to the end. So indices 2, 3, 4 gives LLO. Is valid. That s.substring 2, 5. So it will again be LLO. So begins at 2 and end is 5. Remember, end is exclusive. So we get indices 2, 3, 4 LLO again. The end index 5 equals the length, and that is perfectly valid. The end is allowed to be exactly equal to the length. Okay. Then we have s.substring 2, 6. So it will be string index out of bounds exception. The end of 6, the x is the length of 5. So it will throw. Then we have s.substring 5, right? So we will get a double quote, right? So begin index of 5 equals the length. There are no characters from position 5 onwards, but this is valid. It returns an empty string. This is a edge case and it surprises people. Actually, they expect an exception, but Java says an empty string is a legitimate result. Then we have s.substring 6 and it will be string index out of bounds exception. Begin of 6, x is the length, right? And we have indexOf, right? So s.indexOf xyz, and it will be -1. So xyz does not appear anywhere in hello. So indexOf simply returns -1. No, it will not be an exception. Okay, this is completely different from charAt and substring. indexOf never throws a missing match. It is designed to be used as a search tool where not finding something is a normal outcome. Okay, not an error. So now we come to the practice question. So if you see string is equal to Java with leading space and space at the back. So we call s.trim and then system.out.println s.length. So s holds Java 2 spaces before and 2 spaces after, 8 characters total. So then we call s.trim, but we do not capture the return value. String is immutable, trim does not modify s. It returns a new trim string and we immediately discard it. So s is still Java with all 8 characters, that is 2 spaces before and 2 spaces after. So s.length returns 8, not 4, not 6, it's 8, okay. Then we have system.out.println 1 plus 2 OCA and plus 3 plus 4, okay. So left to right evaluation. So we have 1 plus 2 is equal to 3, both are int, so it will be arithmetic, result is 3. Now we have 3 and string OCA, one side is string, it will be a concatenation. Then it will become 3 OCA, now 3 OCA plus 3 string and int, again concatenation. And so result is 3 OCA 3, now 3 OCA 3 plus 4, that will be string and int concatenation. So result is 3 OCA 3 4, output is 3 OCA 3 4. And the third part is string t certification. So system.out.println t.substring 0, 4. Substring 0, 4 begin is 0 inclusive, end is 4 exclusive. So we get characters at indices 0, 1, 2, 3 and that is CERT, right? CERT. So exactly 4 characters. So answer 4 characters CERT. So answer is B. Okay. 8 then slash 3 OCA 3 4 then CERT. So we have many such questions at javalearn.clustermicro.com. Exactly 1624 questions and 29 full-length practice tests there timed. So it's a fully cloud-native platform. You can register yourself there. And there's a trial period also. You can enroll yourself there and practice for 3 days free of cost.